Hi everyone, we're looking at page 282, statistics 2, section 9.1, scatter diagrams. Now this is a scatter diagram here, and you've probably drawn one of these at some stage before. For this one, it's number of ice cream sold versus average daytime temperature. And what you'll see here is that there's obviously a relationship between number of ice cream sold goes up as temperature goes up, but it's not a straight line relationship. It's not what you might call a linear relationship. But you could approximate it as a linear relationship. And that's really what a lot of this section is going to be about, being able to spot, is there some kind of straight line I can draw through this pattern that will approximate the relationship that I'm seeing here? And then measuring, well, how closely do we adhere to that straight line pattern? So we'll have a look at some questions straight away, and we'll discuss the issues as we go. So question 1 on page 285 here, they're going to ask you about how would you describe this relationship. So again, this section is a lot of it's going to be about language and using the language correctly, I suppose. If you look at diagram A here, you can see you more or less got a straight line relationship here. Okay, so that's called a strong correlation. Okay, whereas say here in C, you've got what might be a moderate correlation, and in D you've got what might be called a weak correlation. Okay, B here, where there's no straight line relationship that you could really discern there, that has no correlation at all. Okay, now the other words we'll use to describe it is, well, if this in this case here, as one quantity goes up along the x-axis, the quantity on the y-axis is going down, it's getting smaller. So this is a negative correlation. So we saw there temperature, sales of, the heat of a day and the sales of ice cream might be positively correlated, like here in C. So the slope is positive, or as one goes up, the other goes up. In A, a negative correlation might be, well, if it's a hotter day along the x-axis, along the y-axis, you might have sales of hot drinks, just for example. Okay, but we call this a strong negative correlation because it's a straight line relationship, very close to a straight line relationship, all of those points. But as one quantity increases, the other decreases. That's a negative correlation. B, you'll say, has no correlation. C has a pretty strong positive correlation, but maybe you might call it a moderate. Okay, and this is just language that we use. It's not very specific. D, you might argue there's a correlation there, but it's weak if there's a correlation at all. E certainly has a good, strong correlation, and it's positive, it's increasing. And F there has probably, you might call it a weak negative correlation. So that's what this question is asking you to do. Which diagrams show a positive correlation? C, D, and E show positive. Negative correlation, A there is negative, and F is certainly negative. No correlation, B. You might make the case that D has no correlation. It's certainly pretty close to it. A strong negative correlation is A. That's a strong negative correlation there. Describe the correlation in graph F. It's negative, probably weak, or you might say it's moderate, something like that. Okay, so just being able to use the language is what we're looking for here. Question 3, the examination marks of a sample number of students in both their mock and final examinations are shown. So here's their mock mark on the x-axis and their final mark on the y-axis. What's the correlation? Well, there's a positive correlation, certainly. A higher mock result results in a higher final mark, or correlates with a higher final mark. And it's a strong enough correlation as well. So you might say a strong and positive correlation, or a moderately strong. What can you say about the relationship between the mock and the final marks of the students? Well, as the mock mark gets higher, so too does the final mark, is the general pattern we're looking at there. Okay, so I'm just going to pull you back to page 283 here and ask you to have a quick read through there and make sure you kind of understand what the language being used there is, because that's the language that's going to be used throughout this chapter. Okay, we'll finish with question 7 here. The scatter graph shows the relationship between the ages and prices of used motorcycles. Describe the correlation shown. Well, you've got a more or less straight line relationship there, and it's got a negative slope. So you're probably going to describe that as a negative, moderately strong correlation. We'll be putting numbers on this in the next section that allow you to be a lot more specific, but moderately strong, you might say. Certainly it's a negative correlation. Is there a causal relationship between the variables? Explain your answer. So we haven't really talked about a causal relationship. Does the change in one variable cause the change in the other? So in this case, well, as age changes, is that what's causing the price of the motorbike to change? You can say, yeah, an older motorbike is gonna cost more, but that's not necessarily always the case. Okay, this diagram on page 285 shows the number of fridges sold increasing as the number of iPads sold increases as well. So there's a positive correlation, and a reasonably strong positive correlation there. But people aren't buying more fridges just because they have more iPads. That's not what's happening. So there is no causal relationship here. Probably what you're seeing here is the effect of a stronger economy and people just buying more of both products. And so this yellow box down here is a really important statement that we're going to be using over and over again, which is correlation does not imply causality. Okay, correlation does not necessarily mean that there's a causal relationship. You'll sometimes see two variables increase together. It does not mean that one is causing another. And this is a really important question in scientific research. And general research is, yes, sometimes you can see an increased relationship between two quantities, but that doesn't necessarily mean that one is causing the other. So you have to tease that out of your data. Okay, so as well as making sure on page 285 to 287, you've got 1, 3, and 7 done in your copy, can I ask you to draw out the scatter diagram in question 4 now yourself and finish that question as well? Okay, see you next time.